Now we are going to solve a problem related to the chapter 5. In this example we are going to see the combustion reaction for the propane fuel. So let's see what is the question. Propane fuel with this molecular formula C3H8 is burned in the presence of the air. So we have a combustion process, actually combustion reaction. Assuming that the combustion is theoretical, it means that the only nitrogen, water vapor and carbon dioxide are present in the products. So we should determine the mass fraction of carbon dioxide, and also for the B part of the question we should determine the mole and mass fraction of the water vapor in the products. Okay, the combustion reaction also it is shown in the figure. As you can see here, our reactant are propane fuel and air, and our products are carbon dioxide, water and nitrogen molecule. So how we can calculate the first part is the mass fraction of carbon dioxide. How we can calculate that? First we should have the equation for the reaction of this fuel with the air. So we know that here we have C3H8 plus air. How we should write the air? As you know, air is a mixture of the oxygen and nitrogen, and the product are CO2, H2O, and N2. Let me write it like this. N2. But what are the moles? We don't know how much is the mole of the product, so we can write like this: Y for CO2, for H2 or water, we can write that. And we can imagine we have only 1 mole of the methane, of the propane, and also we don't know how much air is reacted with this propane, but we know it is theoretical, so we should have a mass balance between them. So we can just write here, we can write A thermal, or we can write X, and here also we can write P. So because this is a theoretical combustion is theoretical, and with some assumption we can write mass balance for this problem. So before we start, we should write mass balance for this equation. We have had an example how we can do that. So let's first start with the mass balance of this equation. Let's write the mass balance for the for the carbon. How we have only 3 molecules of carbon. Here we have Y, so for carbon we have 3 equal to Y, so Y is 3. What about hydrogen? Hydrogen we have about H2. Actually we can write here we have 4 and here Z. So Z will be 4. Then next is for oxygen, we should write like this, which is we have 2 molecules of oxygen here, 2x equal to, or 2y. We can write like this. What about here? Z. So we have, for oxygen, we have a equation like this. By substitution of Z and Y, we will have X equal to 5. What about nitrogen? For nitrogen we have X, 2x, or we can, it is better to write like this. Okay, let me just change it. 2 times 3.76 x equal to 2p. As you can see here, we have 2 molecules of nitrogen here and 2 molecules of nitrogen here, but it should be multiplied by the 3.76. Then by substitution of the x, which is 5, we can have the p as 18.8. So now let's write the equation, the balance equation for this. It will be C3H18 plus 5O2. The molar is here, we have calculated, plus 18.82 give us 3 CO2 plus 4 H2O plus 18.8 and 2. So this is our balance equation for this combustion reaction. Okay, now we are going to find the mass fraction of CO2. The first part of the question was about the mass fraction, if you remember, was about the mass fraction. It's the mass fraction of carbon dioxide. So first we should find this mass fraction of the CO2. We can write this like mass fraction of CO2. Mass fraction of CO2 will be the mass fraction or mass of CO2 divided by the mass of the products. Okay, how we can calculate? If you remember from the lecture session, mass of any material will be equal to N M, which M is the molar mass, or N is the mole, number of mole, actually number of moles of the component. So for CO2 we can write like this: mass fraction of CO2 equal to N, or mole of CO2 times its molar mass divided by, what about products? Molar mass of the products, we have CO2, number of mole of CO2, mole of CO2, molar mass of CO2, plus we have also water in the product, and we have also the nitrogen. So this is the mass of the product. Mass of the CO2 divided by mass of product will give us the mass fraction of the CO2 in the products. So we know the moles of the each component. We know the number of moles of the CO2 and the H2O, and also for the nitrogen we can the mole of them can be find from this equation. The mole of the CO2 is 3, mole of the H2O is 4, and the mole of the nitrogen molecule is 18.8. Okay, so we have all of them. What about the molar mass? We should go to the table for this material to find the those material molar mass. So we should go to table A1 from table A1. The molar mass of this material CO2 in H2O N2. Okay, from the table A1 we have this molar mass for this component, for these substances. For CO2 the molar mass is 45 kg per kilomole. For the H2O the molar mass is 18 kg per kilomole, and for nitrogen it is 28 kg per kilomole. So now we have molar mass, so we can go and calculate the mass fraction of the CO2 in the products. We know the molar mass, and also we know the mole of this component in the reactions. So molar mass of the mass fraction of CO2 is equal to 3 times. I don't write the units, just write the numbers. So 3 times the molar mass of the CO2, 44. Okay, then here again repeat that because it is also a product, plus for the H2O 4 times 18. For the nitrogen is 18.8 the mole, and the molar mass is 28. By calculation you will find the mass fraction of CO2 as this much, 0.18 almost, or 0.181, the mass fraction of CO2. So we have this for the part A. Okay, so let's go to see what is the part B. In part B we are interested to know the mole and mass fraction of water vapor in the products. Okay, for part B we are interested to know the mole and mass fraction of the H2O. In part A we just calculated the mass fraction of the CO2. Now we are interested to know the mole and mass fraction of the water. So first let's calculate the mole fraction of the H2O. The mole fraction of H2O or water will be equal to the mole of H2O divided by mole of the products. Okay, so let's calculate that, but you know that mole of H2O. What are the products? If we see the equation, the products are CO2, H2O, and N2, or hydrogen, or water, carbon dioxide, and nitrogen molecules. So we can write simply like this: mole of CO2, mole of H2O, and mole of nitrogen molecule. Okay, we just substitute this, their value according to the balanced equation here. According to this balanced equation, we should substitute their molar value to calculate the molar fraction of the water in the products. So we have 4 kilomole of the hydrogen. What about the CO2? We have 3 kilomole of CO2. We have 4 kilomole of H2O, and we have 18.8 kilomole of the nitrogen molecule in the product. So the mole fraction will be like this: 0.155 for the mole fraction of the H2O in the products, in the reaction. What about the mass fraction? Mass fraction for the H2 is exactly similar to the mass fraction of the CO2. So we can again write like this. Okay, let me just this. Okay, so mass of H2 divided by mass of the products. Again, you know that the here again M will be equal to N M. So just by substitution, mass fraction of H2O will be like this: N of H2O times M of H2O divided by mass of product. Again, similar to the what we have for the CO2, it will be like this: mole of CO2 times the molar mass of CO2 plus mole of H2O, molar mass of H2O plus mole of N2 or nitrogen, molar mass of nitrogen. By substitution, okay, again we have the mole and also molar mass of the component which we have in this equation. So just by substitution, molar mass of H2O will be equal to N of H2O we have here. We should go to the balanced equation. Mole of H2O is 4, so just substitute. Its molar mass from table A1. From table A1, we have the molar mass of the H2O. It is 18. We just substitute. Okay, so this is the mass of the H2 divided by mass of the product. For CO2 3 mole times the 44 molar mass of CO2 plus molar mass of the water. We just repeat this, 4 times 18 plus, what about nitrogen? 0.8 moles times 28 molar mass. So just by solving this equation, mass fraction of H2 will be 0.986. So this is also the mass fraction is this much, mass fraction of H2 is this much, and mass fraction of the mole fraction will be this much. So these two are the answer of the part B of the question. So we have calculated the mass fraction of CO2, mass fraction of the we calculated mass fraction of carbon dioxide. Also we calculated mole and mass fractions of the water vapor or H2 in the products.